everyone and welcome to this lesson. Today we are looking at trigonometric quadratic equations where functions have the same angle, and we want to determine the general solution, and you remember from our previous lesson what this means. So here is the example. 2 cosine squared theta minus sine theta minus 1 equals 0. Now, before we can solve for this angle, we need to identify what type of equation this is so that we can choose our method for solving it. So again, here's a cosine function and a sine function, and they have the same angle. That is important. But this time, we cannot use the quotient identity. Now, why not? Because one of our functions is to the power of 2. So that completely changes the dynamic of this equation. It changes this into a quadratic equation. So we are going to have to factorize. And what do we always do with a quadratic equation? We move all our terms to one side, and luckily for us, everything is on the left side already. And then here is a very important thing to remember. We want these two functions to be the same function. So the only one of these I can change is this cosine squared theta. Well, because I can see from this equation that 2 cosine squared theta minus 1 reminds me of a certain identity. So let's have a look. The cosine of a double angle can change into this. It can change into this, and doesn't this one look familiar now? Okay, and it can also change into this. So basically, I have 2 cosine squared theta minus 1, which is this identity. So I can change it to this one so that I also have a sine function. Got it? So I'm going to take this part and I'm going to substitute it into the place of 2 cosine squared theta minus 1. So I'm going to open up brackets, and in the place of those brackets, I'm going to take this, and there we go. We do the substitution. Now, can you see that now we only have a sine function in this quadratic equation? This is very important. So now I can use this 1 and multiply it in as distributive law, and we end up with minus 2 sine squared theta minus sine theta plus 1 equals 0. I already rearranged them, and doesn't this remind you of a little bit of algebra? This is the same as minus 2x squared minus x plus 1, which is a proper trinomial. So we don't want this minus here, so I'm going to multiply or divide with a minus all the way through. I'm allowed to do it because it's an equation. So I end up with 2 sine squared theta plus sine theta minus 1 equals 0. And now I can solve this as a trinomial normally. Now this lesson is not about the factorization, so we end up with 2 sine theta minus 1 in brackets, and the other bracket is sine theta plus 1 equals 0. Here we have a zero product rule. So what we do, we equate this bracket to 0 and we solve for theta, and we equate this bracket to 0 and we solve for theta like we did in our previous lessons. So here we have sine theta equals 1 over 2. Then to get the theta, we take the sine as its inverse to the other side, and theta equals sine to the power of minus 1, and in brackets we put this ratio. There we go. And once we solve this, we end up with the reference angle. So theta equals 30 degrees. Okay, now we have to do the same for this bracket. So we write or, and then we move this plus 1 to the other side. So we have sine theta equals minus 1. We move the sine function as its inverse. So we have theta equals sine to the power of minus 1. And please remember, we don't move this ratio as a negative. We only put the positive value in there. There we go. And if we solve this, we get theta equals 90 degrees. These two are our reference angle, and I will underline them. Now the next step is to go make sure in what quadrants we need to work. So we've got this half of the sum and we've got this half of our sum left. So I'm going to start with this. I go to where I only have my sine function and its angle and the ratio. This ratio is positive. So we're going to work in quadrant 1 and we're going to work in quadrant 2. So I write down quadrant 1 and then I just write this reference angle theta equals 30 degrees plus, and this time, because it's a general solution, we will say 360 degrees times k. Why 360 degrees? Because unlike a tangent function, it takes 360 degrees for a sine and a cosine function to complete itself. Then we're also working in quadrant 2. So we have to take this critical point minus the reference angle. So theta equals 180 degrees minus our reference angle of this half of the sum. And then plus the 360 degrees times k. If we solve this first part, we get theta equals 150 degrees plus 360 degrees times k. Okay, but now we also have this part left. So here is our reference angle. Then we go to find out in which quadrants we need to work. So here's our sine function with its angle. It's equal to a negative ratio. So we are going to work in quadrant 3 and in quadrant 4. So this part is going to be 180 plus our reference, which is now 90. And here we go. Theta equals 180 degrees plus 90 degrees plus 360 degrees times k. And we end up with theta equals 270 degrees plus 360 degrees times k. The other quadrant is quadrant 4. So there we go, and we just take this critical point minus the reference angle, and there it is. We solve this first part and we get this answer, which is similar to this one. So in the end, we ended up with 1, 2, 3 answers for this solution. Hope to see you again next time. Bye.